Text mining tools are more prevalent and accessible than ever, and many researchers have sought to use them for educational purposes. What we'll be focusing on today is using a few simple text mining techniques to analyze some educational texts and look at possibilities for automatic item generation focused on reading skills using these techniques. To do so, we used a handful of Python libraries, mostly Spacy, to analyze a few open access educational texts at the word and sentence level. Here are our texts, which are all public domain. For more narrative texts, we have Mary Shelley's Frankenstein and The Souls of Black Folk by W.E.B. Du Bois. For textbooks, we have a science representative in the Introduction to Biology and a humanities representative with the American Yawp. First, we're just going to describe some of the very basic textual properties of the lessons. Here we have the most frequent words in each text, which were not stop words. This gives us a good sense of the most critical concepts in a text. Below that, we have the most difficult words in each text according to the subflex corpus. Educators might use these kinds of analyses to prepare students to tackle the most important or challenging parts of a text. Here we took a frequency band approach to describing the difficulty of the words in our text. So for example, we're looking at the top 1,000 most used words in English according to the subflex corpus and seeing how many of each book's words fit in that frequency band. This should give us a sense of the lexical demands being placed on readers of each text. Now we're going to shift gears from descriptive analytics to more applied ones in automatic item generation. First, we used this framework for generating assessment items related to sentence processing. So we have a table of broad categories of sentence modifiers and lists of words that fall within each of these categories. Using our tools, we can use some simple regular expressions to generate some items. For example, we can search for sentences that contain the phrase such as and replace it with a blank. So that would look something like this. Then to make a multiple choice item, we make the original phrase a response option and then select other words that come from different sentence modifier categories and offer them as other response options. Here's another example. Morphologically focused items by replacing words in sentences that have inflectional morphology with blanks. Then we offer the original word as a response along with other inflections of the same root. So currently we're generating and evaluating large sets of these automatically generated items, and we're looking for other ways to generate them with more fidelity and targeting different reading skills.